dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Alaikum warahmatullahi wabarakatuh. Welcome back, my students. So we are in e-learning programs in Amano schools. So we were here, lesson number 3, or video lesson number 3. So we want to look at this one, video lesson number 4. Still we are in the revision, particularly chapter periodic table. So you came across last two groups, alkali metals and alkaline earth metals. So we want to continue transitional metals. So transitional metals, you see group 1 metals are the first column of the periodic table. Group 2, what we call alkaline earth metals, are the second column. What about transition metals? They are in between group 2 and 3. These are called transition metals. So transition metals, they have a properties. You see, transition metals, they have a properties. They are all metals, number 1. That's why we are calling transition metals. They are all metals. They are harder than and stronger than metals in group 1 and 2. Because group 1 and 2, they are soft enough, but transition metals, they are hard enough and stronger than group 1 and 2. They have a much higher densities than the metals in group 1 and 2. If you remember, group 1 and 2, they have a low melting and boiling point. Generally, they have. But transition metals, they have high melting point and boiling points. They have high melting point and boiling points. They have a high densities. They are less reactive. If you remember, group 1 and 2, they are very reactive metals. Group 1 is the most reactive one. Group 2 is the second. But they are generally most reactive metals. They form a colored compound. If you remember, group 1, they react with oxygen to form white metal oxides. Group 2, same principle. So white oxides are not colored oxides or are not colored compounds. But these transition metals, they form a colored compounds. For example, they can react with sulfate, they can react with oxygen, they can react with any other metal and non-metals. Then they produce a colored compounds. That's why we are calling transition metals. So it is a unique purpose for transition metals. They form a colored compounds. Any single compound, each and every compound which is a transition metal or contains a transition metal, it should have a color. The color is different. You see, chromium, nickel, they have a different colors. Chromium and iron, they have a different colors, but they have a colored compounds. They have a colored compounds. They show a catalytic activity, or most of the time we use like a catalyst, as a catalyst, transition metals. They do not react, they do not corrode so quickly with oxygen. So most of them, they can't react with oxygen to become what? Corrosive substance. Here you have some materials. This is like iron. This is a zinc, say a nickel, a chromium. It is like a gold, say copper. So these are examples of transition metals. Examples of what? Transition metals. What about halogens? Halogens means halo means salt, genes means producer. So these are called salt producers. You see, halogens is also called group 7. Group 7 is the second column, 7th column. So they are all non-metals. They are all non-metals, but they are very reactive non-metals compared to the other non-metals. Which means these non-metals, they can react with metals to form salts. That's why we are calling salt producers or halogens. So element is group 7 is called halogens, which means they are belonging to 7th column. Halogens, they are around now is 6 or 7, but in our table we have fluorine, chlorine, bromine, iodine, and astatine. So these 3 is very important: chlorine, bromine, and iodine. Because of what? Chlorine is a gas, bromine is a liquid, iodine is what? Solid. So below iodine is astatine, above chlorine is fluorine. So if we consider the properties of these 3, which means you can predict the properties of fluorine. If you know the properties of iodine, you can predict the properties of what? Astatine. Because iodine and astatine are solids. They are next to each other. Chlorine and fluorine, they behave in a similar way. Bromine is the middle. It is in between these two. So bromine is a liquid. This is the color. Chlorine is a pale green, bromine is a red brown, iodine is a purple black. Okay, they have a properties. These are the properties of halogens, or what we call group 7. Very reactive, volatile, diatomic nonmetals. Number 1, they are reactive. They are volatile, easily evaporate. They are diatomic. They exist in diatomic. You see some of the atoms, they exist in monatomic, others they exist in diatomic. So they exist in diatomic. They are nonmetals. Always found combined with other elements. So you can't get pure chlorine in our environment. They always exist in a form of compounds. For example, for you to get chlorine, you can get from rock salt, sodium chloride. So they exist in a form of compounds. So we can't get in a form of pure, in a form of element. Their reactivity increases as you go up the group. This is the opposite of the what we call group 1 and group 2 metals. Group 1 and group 2 metals, their reactivity increases as you go down the group. What about, because they are metals, what about the halogens? Their reactivity increases as you go up the group. So fluorine is the most reactive one. Fluorine is the most reactive element. You see here fluorine, chlorine, bromine, iodine, astatine. So astatine is the lowest. What about chlorine? Chlorine is the most reactive one. So these are the reactions. They also react. They can react with hydrogen. They can react with metals. So halogens react with hydrogen to form hydrogen halides. So they react with hydrogen to produce hydrogen halides, which dissolve in water. These halides dissolve in water. For example, hydrogen plus chlorine, hydrogen chloride. Hydrogen plus iodine, hydrogen iodide. Hydrogen plus bromine, hydrogen bromide. These halides, they dissolve in water. When they dissolve in water, they produce acidic solution. For example, hydrogen plus chlorine, hydrogen chloride. Again, hydrogen chloride, which is gas state. It dissolves in water to produce hydrochloric acid. Hydrochloric acid exists in the form of what? Hydrogen ion and chloride ions. Okay, they do what we call displacement reactions. What is displacement reaction? So displacement means what? Taking the place of one element with another element. For example, a more reactive element takes the place of the less reactive element, the position of the less reactive element from this compound. So this kind of displacement reaction. So displacement reaction is a reaction in which more reactive element displaces a less reactive element from this solution, from this compound. If chlorine, it is an example. If chlorine is bubbled into a solution, if you put in chlorine, if you bubble in chlorine in a solution of a potassium iodide, it already contains potassium iodide. The less reactive halogen, which is iodine, is displaced by more reactive element, which is chlorine. So consider here, this is potassium iodide. We added a chlorine, which is gas. If you remember, chlorine and iodine, chlorine is more reactive. So chlorine should take the place of iodine to form potassium chloride. Iodine is the displaced one. So this kind of reaction is called a halogen displacement reaction. A more reactive halogen will displace a less reactive halogen from this solution, from this compound. So the observed order of reactivity of halogens confirmed by similar displacement reaction is chlorine, bromine, iodine. So decreasing here, increasing this side. Or here we have an example. Lithium chloride, sodium bromide, potassium iodide. So these are the compounds. We want to add this chlorine, bromine, iodine. If you remember, it looks like a green, say brown, red brown. It is a purple black. So you can see these three. So is it possible here? I want to write something here. Okay, is chlorine, for example, if you have a chlorine with lithium chloride, can chlorine displace chlorine? No, there is no reaction. What about bromine? If you put in bromine with chlorine, can bromine displace chlorine? No. It can't displace. What about iodine? No reaction. There's no reaction. It can't displace. What about if you put in chlorine with a sodium bromide? Yes, so the product should be what? Sodium chloride. The displaced one is bromine. Can chlorine displaces what about this one? Bromine, no. Bromine, they have the same reactivity. Iodine can displace bromide ion, no reaction. What about here? We have a potassium iodide. If you add chlorine, the product is what? Potassium chloride. If you put in bromine, this iodine is displaced, so it's supposed to be potassium bromide. What about iodine? Can displace iodine? No, they have the same, so no reaction. So you can complete this kind of table like this. So this is called a displacement reaction. So how many times you have a displacement reaction? At this time we have a displacement. So 3 times we have a displacement. The remaining is not a displacement. Okay. Shall I continue? So this is what we call, this is a new subtopic. This subtopic is called Halogens reactions. So Halogens reaction is oxidation reduction reaction. It contains 2 different reactions. So oxidation reduction reaction is called Halogens reactions. So oxidation reduction reaction is both oxidation and reduction occur simultaneously together at one time. So oxidation is a loss of electrons, reduction is a gain of electrons. So we can consider this. So oxidation is loss of electrons, reduction is what? Gain of electrons. So consider here, still we are in displacement reaction. So the displacement reaction itself is a Halogens reaction. So we want to consider here. For example, we have chlorine here. This is chlorine molecule. We want to add potassium iodide. To produce chlorine takes the place of iodine. So potassium chloride will form, and iodine, this is the displaced one, and iodine is the displaced one. If I try to balance here, this is here is 2, and here is 2, What about the charge? So I want to get the charge. So this is the charge. So if the element or the molecule is alone, the charge is 0. You see, potassium is group 1. This charge is positive 1. Iodine is negative 1 because if it is group 7. Potassium is group 1. Chlorine is negative 1. What about iodine? At this time is 0. So start from here. You can consider iodine. This iodine up to here. What about chlorine? It came from 0 and it became here. So chlorine it came from 0 to positive 2 to negative 2. Chlorine, the oxidation number of chlorine is 0, which means it doesn't lose a single electron, and it doesn't accept a single electron, which means chlorine it is a neutral at this time. It is 0. The oxidation number is 0. What about here? It is negative 1, which means it accepts 1 electron during this reaction. So it accepts 1 electron. So gain of electron indicates reduction. So chlorine was reduced. So this kind of reaction is reduction. What about here? It was negative 1 before the reaction. At the end of this reaction, iodine becomes 0, which means it accepted, it lost this electron. It already it was -1. Now it become what? 0, which means it become oxidation. It become what? Oxidation. So I can say this displacement reaction we can also call redox reaction because it contains reduction and oxidation. Okay, my students, we want to stop there. Thank you very much.